Hello guys. In the previous episode, we have written a classifier to identify different species of iris dataset. Today, we'll write up a basic pipeline for supervised learning, and I'll show you how multiple classifiers can use to solve the same problem. Then I'll explain what it means for an algorithm to learn something from the data. Imagine you're building a classifier to identify an email whether it's a spam or not. That's just a function which labels emails as spam or not spam. As you can see, the features are the inputs given to a function and the labels are the output which is returned by the function. But before we put into production, we need to be sure that how accurate will it be to classify the emails that were not in your training data. We need to verify our model and make sure it works well before we deploy them. So what we need to do is we need to test our model for new test data which our classifier is not aware of. To do that, what we can do is we can classify the data into training data and the testing data. Training data is the one which is used to train the classifier, and the classifier learns from the features and the labels which is given to it. And the testing data are the other set of data which are unknown to the classifier, which is used to test the accuracy of the classifier. These are the new sets of data which is classifier is not aware of. Let's look at the code and understand it. I have created a Python script called comparison of classifier.py where we are going to compare two classifiers and their accuracy. What we are doing is we are actually using the iris dataset and we are loading it to the function in this line as we have done it in the second episode, and we are storing the iris data and the target into variables x and y. Why? This is what we have not seen in the previous episodes. To explain this, we can look into the function f of x equal to y. Every algorithm is a function which takes some parameters as input and returns the label as output. So here the x is the features of that particular data set and the y is the label which is written from the function. The example function looks like this. Def classify, which takes the parameters as features. It may have other parameters with it, including, and also the logic part is what we write in between that function to perform the action. In supervised learning, for this episode, we are using the inbuilt functions as our logic, which does the actual machine learning algorithm logic and returns the label to the function. So what we are doing is we are classifying the iris dataset which is loaded to the algorithm, and we are testing the model which we have built based on the training data. So first in this line, what I'm doing is I'm importing train set split, which is from scikit-learn library, and I'm splitting the splitting the iris dataset into two sets. The first set is x-train and y-train, which are the features and labels for training data, and x-test and y-test are the features and labels for testing data. I'm splitting the test data based on the size 0.5. What it does is it exactly splits the whole data into 50-50. So we have 50 training data and 50 50 testing data. We are going to use 50 testing data in order to get our classifier's accuracy. Here in this line, I'm importing tree and I'm using decision tree classifier in order to predict or in order to build the classifier. I'm passing X train and Y train, the features and labels of the training data, into a function fit, which is inbuilt function from scikit-learn. What it does is it actually learns the features and labels which are given to the function. Here what I'm doing is I'm just printing the predictions which is done by my classifier, which is decision tree classifier. That is what I'm using here. And then we are going to check the accuracy of our classifier by supplying the testing data. Y test is what the testing data is. So our classifier is not aware of these testing data. So we'll run it and execute it and see what it exactly predicts and what is the accuracy of a classifier. So I'm running it. As you can see, it prints its predictions and the accuracy. Accuracy is about 0.97333333, so on. So this value may be different while you run the script because it depends on how exactly the test data and the train data has been classified from your algorithm. This is randomness. The randomness in the classification may result in different levels of accuracy, but I'll make sure that it is above 0.9 always. Now what we are going to do is we used decision tree classifier as per now, and now we are going to use k-neighbor classifier. This is a new classifier which does the same thing, and now we are going to check the accuracy of this k-neighbor classifier. I'm going to execute the script now. As you can see, now the percentage of accuracy is 0.96. So both of the classifiers are almost predicting the same, and their accuracy is somewhat equal. Now when I say the algorithm is learning from the training data set, what I exactly mean is we are going to explain it in detail now. So consider we have X and Y coordinates, and we have green and red boxes on the coordinates. So let's say we have a straight line y equal to mx plus c, where m is the slope and c is the y-interception. So based on the values of x, we can define y, the straight line. Let us say this is our classifier now. So the straight line is our classifier, which takes x, the features, as input and predicts the label y, and it draws a straight line. Let us assume we want to classify a new box which is given to the algorithm as an input, and we need to classify it as whether it is a green or a red box. So what we can do is, for example, we can put some box like this here, which is taken from the testing data. The algorithm is not aware of it. What we can do is, if the box is in the left side of the straight line, then we can predict it as a green box. If the same box comes here in the right side of the straight line, then we can predict it as a red box. So what we are exactly doing is we are fitting the straight line based on the parameters given to it. So each and every time when you give the parameters, the straight line fits in the coordinates. So at last the prediction will be accurate, so that the algorithms learn from various huge amount of test data, and finally it fits to some values of x and y, and it learns based on the values provided. And one more thing, guys, you can go to playground.tensorflow.org and you can play with the various data and the neural networks that has been given over here. You can see, you can select the data set what you want to use. This is the most complex one in order to learn, and you can set the neural networks and you can run it and write how exactly the function fits and classifies the data. As you can see over here, if you select this different data set, it takes and it is now the classifying the data based on the algorithm of the neural network. So it definitely needs one more episode, but for now you can go ahead and look into this website and try to play around these data sets. Thank you.